Here's where we're at, man. We've got our hierarchy filled out to this point. We kind of talked last time about, dude, this is all you need to know. If you have this stuff memorized, you will totally, totally, totally dominate the bottom, because we talked about people's parents. So let's start first with the rectangle. Would you believe the rectangle in this family's tree, his parents are the isosceles trapezoid and the parallelogram? Like if those two got together and had a baby, they would have themselves a rectangle. Definition, I guarantee you'll get that right. What is the definition of a rectangle? Boom. 4 right angles. And then next is the symmetry lines. You know, the symmetry lines, you got to look at where it came from their parents. Let's see if the rectangle is even going to have any symmetry lines, right? Okay, here's, I don't care which one's mommy and daddy or whatever like that, but right here, does the parallelogram have any symmetry lines? Nope. Does the isosceles trapezoid have any symmetry lines? What do you think? Does it have any? It has one. So if either mom or dad has something like that going on, then the baby will have it. Will a rectangle have any symmetry lines? What do you think? Yes or no? Big guy, yes. The question is where. It'll be in the same aspect of this. Would you believe the perpendicular bisector of the bases is, like if you go perpendicularly through that, that's where the symmetry line would be. Holy crap, dude. Help me. It's been a while. Where are the bases of a trapezoid? You know, I know it's isosceles, but what makes the bases the bases? The bases are the parallel sides. So question for you. Boop, boop. Are those sides parallel on a rectangle? Yes or no? Yep. So if I perpendicularly bisect those, I'm just going to kind of sketch one and don't do it. If I perpendicularly bisect those, wouldn't that be a symmetry line right there? Holy crap. Are these sides parallel to each other in a rectangle? So if I perpendicularly bisect those, wouldn't that also be a symmetry line in that case? How many symmetry lines does a rectangle have? 2. And here's where they're at. The perpendicular bisectors of the sides. There are 2 symmetry lines. The perpendicular bisector. Instead of saying the bases this time, we're going to call it the sides, just because it's like, all right, it's like all of it. So there's the symmetry line. Last time we talked about peanut butter every day. Like, don't you have a big old capital B right here underneath this parallelogram because the diagonals bisect each other? And don't you have a big old capital E underneath here because the diagonals are equal to each other? Let's put them together. What should be true about the diagonals of a rectangle? It'll be this, right? What does it really mean? What does the B mean? They bisect each other. And what does the E mean? They are equal. Whatever order you want to put those in, I don't care. You could say they are equal and bisect each other, or you could say they bisect each other and are equal. Right? It's like they're both there. But to me, the diagonals is almost a freebie if you know peanut butter every day. Peanut butter every day. So this was your bisect each other, these were your equal, and this is your bisect each other and equal, or equal and bisect each other. So let's talk on this guy. Here's the rectangle that I have drawn. I've got a red diagonal and I've got a green diagonal. I'm going to ask you 3 questions. Question number 1, boop, is that angle right there 90 degrees? Discuss with neighbor. This is what's true about the diagonal. Let me switch colors. This is what's true. What word would need to be in there if they say that those would be intersecting at 90 degrees? Perpendicular. That's up there, right? That's not what I'm talking about. It's down here. Those are not. Here's the next question. Does the red one cut the green one into 2 equal pieces? And does the green one cut the red one into 2 equal pieces? What do you think? Yes, right here. Here's the last question. Is the red one the same length as the green one? What do you think? What word is in there that makes you say yes? They are equal. So how would I mark that? The red one and the green one are the same length, and they cut each other into 2 equal pieces. So should this be true? Bing, bing. Should that be true? Yep. What kind of markings do you want me to put on here? Singles, doubles, triples? What do you want? What do you think? Does that work? I'm going to make up a length. Pretend that is 5. How long should this guy be then? 5. Awesome. How long is the red one? Total length of the red one. How long is it? 10. How long should the green one be? It better be 10, right? So doesn't it also get cut into 2 equal pieces? So what's each piece? 5 and 5. So how many tick marks should I put on them? Singles, right? Would you agree that all of those are the same length in that case? Yeah. Nice. Let's go to our practice worksheet and do some problems about rectangles. Again, they're telling us in the instructions that this is a rectangle. Let's take this information and see what we can do with it. They don't have anything in the picture per se, but we've just got to see. It says if the distance from A to C is 2x plus 13, A to C, wow, isn't that like this whole guy right here? Isn't that a diagonal? Cool. What's the other thing that they give me? The distance from D to B, wow, isn't that the other diagonal? Look to your hierarchy and see what should be true about those in a rectangle. Those are the diagonals. And you know the whole length of each one, right? You know the whole length. So come up with a plan. Those guys are definitely equal and bisect each other, correct? Do you need both of those pieces to solve for the variable that they want? Which piece is the most important one? If you know the whole blue one and the whole green one, which one really matters? That they are equal to each other, right? So it's true that they bisect each other. I don't care about any pieces. I care about this. So let's take the blue one of 2x plus 13, and since it's the same as the green one, how about we set it the same? Aren't the diagonals of a rectangle equal to each other? Please solve for x. Yeah. Then let's be careful and see what they want us to find. They want us to find the distance from D to B. Isn't that the whole green guy right here? Let's substitute 7 in for x. Let's do that mentally. What's 4 times 7? 28. Take away 1. Boom. Distance from D to B equals 27. How do you feel about that? Let's check out the next guy. If the distance from A to E, ooh, man, that's just this little guy. Would you believe that's not the whole thing, right? That's not the whole diagonal right there. So I'm going to put them in the picture. 3x plus 3. And the distance from E to C, that's just this little nugget right here, is 5x minus 15. Find the distance from A to C. Come up with a plan of what you could do to set up an equation to solve for x, or set up a scenario. It may not even be an equation. We will set those equal to each other because the diagonals bisect each other. So 3x plus 3 equals 5x minus 15. All of these are the questions on your test. Some will be proofs, some will not be proofs. But remember, filling out the hierarchy is only one page of the test. Then you have to kind of understand how to do all these other problems. Let's see what we got here. Why don't we try number 3? If you'd please pause that video and give this a try. Put some information in the picture, see what you can do. Because this is a rectangle, those two angles, don't they like totally have to add together to equal 90 degrees? Like that whole big guy right there is totally 90, right? That's that whole guy. So nice thought on trying to think they're equal to each other, but that orange guy is not a symmetry line. So this dude plus this dude add up to be 90. What's the justification for that? Starts with a D. The justification of why that angle right there is 90 degrees. Definition of rectangle. Isn't that part of the definition? Right? So 5x equals 85, and then x equals 17. You guys cool with that? Nice. If you have any questions like that and you're not sure what to do, holla at me. But we're going to move forward to proofy time. Let's get started by writing the given. RSTV is a rectangle. There's no symbol for rectangle. You know, we got that parallelogram symbol that we did last time. U, let's put those as 2 separate lines, if you would. That U is the midpoint. So I'm going to go, when they give me 2 things, U is the midpoint of segment VT. 2 separate things given to me. So I like to stack them on top of each other. Our old friend, the midpoint, is back. Even though it's been a while, I hope your proof experience in this class realize if they give you a midpoint, aren't we going to have to use its definition somewhere in there? So I'm going to start with that. I know they gave me a rectangle. I got all kinds of things that I know is true. Let's use that midpoint. Here's segment VT, right there. If U is the midpoint, could you mark for me what that means in the picture? How do you feel about boom, boom? Yes or no? Can I do that? The dangerous part about these definition things is we mark them, but we forget to write them down. Don't forget that you need to then go to step 2 and write that dude down. Segment VU is congruent to segment UT. Please line up your steps. Here's step 2 as a statement. Step 2 is a reason. Please tell me that reason. What is that? Definition of midpoint. Cool. I haven't even looked at what they wanted me to prove yet. I know when they give me a midpoint, I'm going to go need to use its definition. Let's see what they want us to prove. Prove, these two triangles congruent to each other. All right, cool. I'm going to give you time to think. Recording again. So it has been suggested from the class that maybe we could do this, that this guy, wham, and this guy should be the same. Cool. How many tick marks would you like to put on it? Do we have any evidence that that orange guy and this blue guy right here have to be the same length? Have they told us any of that? I know they look the same. I won't lie with it. They look the same. Do we have any evidence that they have to be the same length? So how many ticks do you want to put? 2. Boom, 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 boom. So step 3, I'm going to say that segment RV is congruent to segment ST. The weird question is why? Why would that happen? We have determined that, yes, this is a rectangle, but it is also a parallelogram, so we can rock with parallelograms imply that opposite sides. You want an equal sign or a congruent sign, guys? Whatever these are. All right, so we're going to say congruent. Cool. I like that. That's nice. Can we prove those two triangles congruent right now? Like side, 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 side angle, side, etc. Do we have enough info right now to do it? Nope. So let's talk. Let's see. Remember, we were talking earlier, not on recording, that we want to avoid hypotenuse leg if we possibly can. Is there anything I could do to get this green dude the same as that green dude? Let's discuss. Then we can get like side, side, side. Could we possibly get those congruent? Just out of all the deliberating, we could not find a way that was provided in the picture to get these to be the same. I'm going to say we need this. Does anybody know anything about those? Yeah, so here's what we'll do. This is kind of tricky. We're going to, instead of say that they're right angles, how about we say measure of angle V equals how much? What does the measure of angle V equal? 90 degrees. Semicolon, measure of angle T equals 90 degrees. Reason, how did I know those are both 90 degrees? Yeah, that's the definition of what? Rectangle. Go mark it. And although it looks like we could do side angle side right now, you know, we don't have to do hypotenuse leg, which is cool. Looks like we could do side angle side. I have to get angle V and angle T to be the same, written down in my proof. I don't have V and T the same written down in my proof. But is there something in both of these lines that could maybe be crossed out? What could you cross out? The 90s. And we're going to do a little extra cheating. You know, you see how we're switching from measures equal? I'm going to go back to congruence instead, so I'm cheating. There's really a lot of work that comes with this, but I don't care. I'm just going to go straight to angle V is congruent to angle T. Why could I cross out what was in common and write those leftovers congruent to each other? That's the transitive property. If you're watching this in video land, I know you can't actually go straight to that, but I don't care. I think this is to the point, you know. We're going to go straight to it. Then, why could I prove those two triangles congruent? Which of the 5 ways works? Side angle side. So step 6. Use the statement up here. No need to even think about it. Triangle RUV congruent to triangle SUT by side angle side congruence here. To use side angle side, you have to have 2 sets of sides congruent to each other. Here's 1. Here's 2, and you have to have a set of angles congruent to each other. Here's that set of angles. That's why you have to do the transitive property in there. That is not an easy proof. I think we could see it and mark things a lot easier than we could justify it. You know, it's like, well, I know these are 90, and like this is this. You know, it's like to mark it up real easy, but to write it down, kind of picky. Cool. All right, let's go to a rhombus. Please get his definition. Rhombus's definition has 4 equal sides. Right? You knew that. The symmetry lines is the hard part for people until they figure out how these hierarchies marry together. The parents of the rhombus are the parallelogram and the kite. Since we're talking symmetry lines, let's look at these guys' symmetry lines. Old parallelogram had none. We get no symmetry action from the parallelogram. Nothing's happening from that guy. Don't we get all of our symmetry line stuff from the kite, right? Where is the symmetry line for the kite at? Through the what? Through the ends. You're going to have to refresh me. It's been like a long time since we talked about where are the ends of the kites. How do you know where those are at? Remember? Tell me why these are the ends of the kites. Why are those the ends of the kites? Tell me about those blue sides right there and these green sides right here. What's so great about them? That's where the two sides of the same do what? Touch each other, all right? You cool with, it's been a while. I used to make students write it on the hierarchy. If you want to write that on your hierarchy, the ends are where the two sides of the same touch each other at. Those are the ends of the kite. Every single kite, if you go draw a line through the ends, that's going to be a symmetry line. The symmetry lines are where two sides of the same touch. I'm just going to label these A, B, C, D. Please don't do that. You don't need to, but A, B, C, D. Question for you. In that rhombus right there, do two sides the same touch each other at point A? Right here? Two sides the same touch? Two sides the same touch each other right there? If I was to draw a line through there, aren't those like the ends of this kite? Remember, rhombus is a kite, right? That was mother, you know, so it's a kite. Isn't that a symmetry line right there? Another question. Do two sides the same touch each other right here? Do two sides the same touch each other right there? Do two sides the same touch each other right there? So if I was to connect those together, wouldn't that be a symmetry line also in that case? How many symmetry lines does a rhombus have? 2. Where are they? Could you take I know I didn't draw them as lines, I drew them as segments. What the heck did I just draw in? Those two things, it starts with a D. Those two things are the what? The diagonals, right? Would you be down with the fact that there's 2 symmetry lines? They are the diagonals. The diagonals are the symmetry lines of a rhombus. And then let's go back to peanut butter every day. You got yourself a big fat P right here. You got yourself a big fat B right there. When you marry these together, for the diagonals, shouldn't the P and the B come together and give you some peanut butter in that case? What does P stand for? Those diagonals are what? Perpendicular. What does the B stand for? Bisect each other. So guess what's true about these diagonals? They perpendicularly bisect each other. Those diagonals perpendicularly bisect each other. You can use the symbol if you'd like. Perpendicularly bisect each other. All right, I'm going to ask you the 3 questions again. Here's my little rhombus drawn off to the side here. So, come on, man. Boom, 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 boom. Here's a red diagonal and a green diagonal. Question 1, do those intersect at 90 degrees, yes or no? What do you think, yes or no? Yes, they do, because those diagonals are perpendicular. Does the red one cut the green one into 2 equal pieces? And does the green one cut the red one into 2 equal pieces? What do you think, yes or no? Come on, guys, I know we're tired. Yes or no? Yeah, they do. So I could go double, 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 double. Here's the last question before I mark that green guy. It's like, should I put double tick marks on it? Should I put triple tick marks on it? It's about this. Is the red one and the green one the same length? What do you think? Are they the same length? What word needs to be written in that blank for me to know they're the same length? They would have to be equal to each other. So they are not. So wouldn't this have to be triples and triples, you know? Like this red one could be 5 and 5, and that green one would have to be 6 and 6. They cut each other into 2 equal pieces. They intersect at a 90, but they're not the same length. Let's go back to the worksheet, and I cannot stress how crazily wild it has been of how poorly people do on rhombus questions on this test. So let's take this slow. This is a rhombus. They told me so. Cool. Find all angle measures and all side lengths. Put the answers in the picture. we're going to start just like this is a kite. Here's an interesting question. Is this a kite? Yes or no? Is a rhombus really a kite? Yeah, it's below it. You know, that always, sometimes, or never. So I'm going to start right here. Does anybody know what that angle measure has got to be right there? 90 degrees, because those diagonals are perpendicular to each other. So we're going to go boom, 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 boom. All of those guys. If you would like to color things, you know, the next thing I would probably do is go color the symmetry lines. Does a rhombus have any symmetry lines? Feel free to look it up. I know it's new to you. Does a rhombus have any symmetry lines? Where are they at? The diagonal. So boom, there's one symmetry line right there. Boom, there's a second symmetry line right there. Yeah. I'm rolling angles first. I don't care what order people go in. I'm rolling angles. Please tell your neighbor right here, boom, how much this angle right here should be. If this guy is 32 degrees and the red guy is a symmetry line, which he is, how much should that angle right there be? 32 degrees, baby. Any questions about that? Use the green symmetry line. Excuse me. Use the green symmetry line. If this was 32 degrees, somebody else should be 32 degrees when you hop over the green symmetry line. Shouldn't it be this guy right here? Do you see how those are symmetrical to each other in that case, over the green symmetry line, right? How about this angle right here? How much has that one got to be? 32 degrees. Rhombus. All kinds of crazy stuff going on. You also have 4 different triangles drawn in the picture. Here's one of them right here in orange. This angle is 90 degrees, this angle is 32 degrees, and this angle is unknown. But don't you know something about all 3 angles? What should they add up to be? 180. Find that missing guy right there, baby. What you got? 58. And this is like a snowball rolling down a hill. You know, it just keeps getting bigger and bigger and bigger in that case. When you find this 58, guess how much this angle is right over here, since there's a green symmetry line right there. 58. How about this guy down here over the red symmetry line? What's that one got to be? 58. And that one, 58. How do you feel about that with my rhombus? Those are just all the angles. Let's go find its side lengths. On the homework quiz, some people kind of made a boo-boo and just forgot about this. See, this dude right here is 3. How long should that guy right there be? 3. You could use symmetry to understand that, or you can know that the diagonals also bisect each other. Here is a 4. How long is that guy right there? 4. And then because we have right triangles all over the place, check out this orange guy right here. This leg of the orange guy is 3. This leg of the orange guy is 4. I am missing the hypotenuse. 3, 4, what? 5, 5, 5, 5. It's a rhombus. Rhombuses should be the easiest ones compared to kites. Weird how they get missed a lot. Yep. Number 7. Try that guy. Take the info, put him in the picture. See what happens. So here's angle ABD. That means that 60 degrees goes right by the middle letter, which is the vertex. They say find the measure of angle BDC. BDC, that's this angle right here. There's lots of ways you could find that. Lots of ways. I would take a suggestion. First, what do you got for an answer? Does anybody have an answer? 30 degrees? This guy right here? Nope. 60 degrees? Okay. I'll give you a couple of justifications of why. What's one justification of why? Anybody? Symmetry line, okay? Can't quite use symmetry 100%. You have to do a couple of things. Here's a symmetry line, but those two are not symmetrical to each other over the symmetry line. Could you believe that this one and this one, that purple one and that red one, are symmetrical to each other, and then wouldn't that jump across using the other symmetry line in that case? That works. You do the same thing. You say this one comes down here to be 60, and that's got to be 60. That works. What's another thing you can justify it with, especially since we don't do much with symmetry lines in a proof? Does anybody know what kind of angles those two are? Yep. Those are definitely on alternate sides of that red line. Aren't they between these two orange sides right here? You have to have parallel lines first, though. Does a rhombus have parallel lines? Who is the rhombus's parent? One of them is the parallelogram. So doesn't that totally have parallel lines? Cool. One more of those. Meow. Let's see what happens. This is interesting. You cool with my 3x minus 1 being put in the picture like right there? What the heck is 16? A lot of people just go straight for that thinking to be E to C because they gave me like half of a diagonal there. They think it's got to be the other. How long is 16? From where to where, I should say? A to C. Isn't that the whole thing, right? So how do you put that in the picture? Well, there's a lot of ways. I'm not going to put a 16 in my picture at all. Right? I'm not even going to put the number 16. I would rather put a different number. Anybody know what numbers? We'll put two of them, and they're the same. Guess what numbers I want to put? 8 and 8. Why is this got to be 8 and that got to be 8? Does anybody know why that has to happen? Tell me about that thing right there. The diagonals perpendicularly bisect each other is one way. People who say, well, the green one is a symmetry line also, Mr. Bonestill. You know, it's like, shouldn't the 16 be 8 and 8? So what could I let 3x minus 1 equal, y'all? 3x minus 1 has to equal how much? 8. 8. This guy and this guy have to be the same. So if this whole red dude is 16, because it got perpendicularly bisected, that's 8 and 8. Cool? Yes? No? Maybe? Questions? Nice. Let's try 9. If the distance from A to B is 26, cool. And the distance from B to D is 20, cool. 20. You know what? I don't know if I want to put that in there. I'm not sure that I want to put a 20 in the picture. What could I put instead of a 20, y'all? 10 and 10 might be a little more helpful for my eyes. 10 and 10. You guys okay with that move right there? They say find the distance from A to E. That's this green nugget right there. I will take suggestions after I give you a moment to think. If you're wrong, we'll fix it. What do you think? How does that help? Struggle bus stopped at everyone's house over the long weekend. What's it called that we want to do? Starts with P that she's trying to do. She squared somebody already. We'll do the what? We've got to have a right triangle to do that. Do we have a right triangle? Yep. So, name the 3 sides of that triangle out loud from smallest to largest. Look at your neighbor and say them out loud. 10, 24, 26. You have to be pretty good to realize what are the 3 that I made you memorize. Who's the first one? 3, 4, 5. Next one? 6, 8, 10. Who's the third one? 5, right? 12, what? Talk to me about the smallest guy, 10. How does he relate to the number 5? 10 is twice as big. How about 24? How does that relate to the number 12? Twice as big. How about 26? Is that twice as big as the 13? You have to be really, 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 really good. But 10, 24, 26 is a 5, 12, 13 times 2. So, like, have you even seen that with the 3, 4, 5? Who's the second most popular triangle around besides 3, 4, 5? The what? 6, 8, what? Isn't that all of these guys doubled, right? What if I tripled them all? Wouldn't it go 9, 12, 15 in that case? If you triple them all, you'd get that. You could quadruple them all. You could do, like any kind of multiple of those you could end up doing also. I don't know how many brains can handle memorizing a full-on freaking list of right triangles. But if you can handle 3, 4, 5, 6, 8, 10, and 5, 12, 13, you'll be in great shape. And if you've got a really cool math brain like mine, because I'm a nerd, you might be able to see multiples of those. You're like, oh, if this is 10 and this is 26, you know, that other one has to be 24 in that case. It's up to you. I think most of you will feel very comfortable just doing the Pythagorean theorem. Okay? So, all right. Can we get recording? How? I'm going to just go with the angles. How much should that angle right there be, y'all? Symmetry line. That's supposed to be 7 out of 2. 67 degrees. Symmetry line. Come on, dude. How about over here? What should that one be? 67. And how about here? When you get used to rhombuses, you know you're going to have 4 of those dudes right away. It's like this one, this one, this one, this one. Then how do you figure this other angle out? The fact that this is 90, we already kind of did that. This is 90, this is 67. Doesn't that have to be 23 degrees? Because all 3 angles in the triangle add up to be 180. So then 23 is all around the house. Boom, 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 boom. Thank you. Symmetry line. Good with those. Let's go side lengths. Don't forget the little details. This little guy is 5. How much should that guy right there be? 5. Awesome. Let's do some basics also. Since it is a rhombus and one of the outside guys is 13, shouldn't they all be 13? Because it's a freaking rhombus, right? It's got 4 equal sides. 5 blank 13. Who's that other guy? You will thank me someday. That saves us a lot of time. They're the 3 most popular right triangles for a reason. You see them all over the place. So, cool. Let's go back and see how good you can do it. This is it. It's finally time to do the bottom guy. All right, we got it all up here. Let's roll with the square. Please get his definition. Doesn't matter the order that you put them in. They both have to be there. 4 right angles and 4 equal sides. You know, if you say 4 equal sides and 4 right angles, same thing. It's all got to be there. I want to see how smart y'all are. Could you figure out the total number of symmetry lines that a square has from its parents, from him and from her? So we have decided that it will have some. Let's call this mom over here. Mom has 2. Where are they at? That's over here. I'm on the rectangle. Rectangle has 2. It has the what? Perpendicular bisector side. So I'm going to just roughly draw them in. I'll draw them in more accurate later. Wouldn't that be that one and that one? Those 2 green guys. How many does the rhombus have? 2. Are they the same ones as the rectangle, or are they different ones? They're different. Who are they? The diagonals. So if I could draw it in, how many total symmetry lines does that guy have? 4. Accidentally, sometimes when people draw the lines, they count up all these arrowheads, and there's 8 arrowheads. You know, it doesn't have 8 symmetry lines. Would you believe there's only 4? But there's going to be 8 arrowheads because each line has 2 arrowheads, right? So it's got 4. Where will they be at? So easy, guys. So easy. You put this in there, meow. You put the perpendicular bisectors of the sides, and you put this in there, the diagonals. They just get married together. So there's your 4 symmetry lines. They are the diagonals and the perpendicular bisectors of the sides, or the other way around. You just put it all in there. If you know rhombus symmetry lines and you know rectangle symmetry lines, you put them together. So 4 total, boom, you'll put that guy, bam, and then you'll say the diagonals, okay, that came from here, and the perpendicular bisectors of the sides, boom, that came from there. Again, like I said, if you switch that order around, that's cool. And here's where we're at with our peanut butter every day. We got some peanut butter going on over here. We got some butter every day going on over here. I'm going to put them together. Should these diagonals of a square be perpendicular to each other? Yes or no? Yep. Should they bisect each other? Yes or no? Yep. Should they be equal? So put them together. The diagonals perpendicularly bisect each other and are equal. Are equal and perpendicularly bisect each other, or the other way around. They are equal and perpendicularly bisect each other. They are equal and perpendicularly bisect each other. For the last time, I'm going to ask you those same 3 questions. Here's my square with a red diagonal and a green diagonal. Question 1, do they intersect at a 90? Yes or no? Yep, right there. Question 2, does the green one cut the red one into 2 equal pieces, and does the red one cut the green one into 2 equal pieces? Yes or no? Yes, bisect each other. So, boom. Is the red one and the green one the same length? Yes or no? Yes. This is the only one that you can say yes to all 3 of those questions. It's got the P, it's got the B, and it's got the E. If I could go back to the early 2000s, this is as close to Stacy's mom as you got. Because Stacy's mom has what? got it going on. The square has everything, dude, you know. The diagonals are perpendicular. They are bisecting each other. They are equal. The square is the king of this family tree, right? Isn't it the most specific thing that you got? So there you go. Again, I told you, here's your P, here's your B, here's your E, right? What was true about these diagonals? We didn't talk about it too much in this class. I did it in the other one. What's true about those diagonals? Was there any PBs or E's or anything going on? Was there anything fancy at all? Nothing fancy. So you can handle that. Then you marry them together. These diagonals are perpendicularly bisect each other. These diagonals bisect each other and are equal. And these diagonals are perpendicular and bisect each other and equal, or however you want to phrase it in there the way it's supposed to be, right? That is a huge chunk of the hierarchy taking care of you with peanut butter every day. Your job, if you choose to, is to come up with something cool to figure out the symmetry lines. You know, I'm not going to give it all to you. You have a brain too. It's like, what's true about the symmetry lines? Then you got a few rando properties that you need to remember. A very tough definition up here in kites that you need to know. You know, that's a hard definition. Tough property right here, you know. Maybe a weird little property right there, you know. But I think it's very, very doable for a class as smart as you guys are. Cool. Let's go do the last questions. Let's draw all the symmetry lines and mark them. I'm going to let you do all 4 of them. Shape recognition, like use the hierarchy, draw all the symmetry lines, work with the neighbor. Make sure you get them marked correctly if things happen. Like if they bisect each other, put the tick marks. If they intersected at 90, put the right angle boxes and all that kind of stuff. So give it a shot. Pause the video, get that done. Sorry, apparently the worksheet was missing a little arrow right here for this parallel line. That's supposed to be parallel right there. So we got a rhombus on 12, a rectangle on 13, an isosceles trapezoid on 14, and a square on 15. Draw the symmetry lines in. All right. I'm going to go draw them all in and then mark them. I'm going to get my arrowheads going. You should put arrowheads on your lines. So boom, 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 boom. Well, that's way off. Boom, 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 boom. I'm very scared that this is what you're going to put on the test. Close, but no cigar. That is definitely not good enough. We've got to mark them. So let's go back. Here's the rhombus. There are 2 symmetry lines. They are the diagonals. You can't look that up. Shame on you. What's true about them? The diagonals do what? Perpendicularly bisect each other. So boom, 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 boom. Boom, 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 boom. Isn't that also going on? Be true. Where are the symmetry lines for a rectangle? There's 2 of them, but doesn't it say the perpendicular bisectors of the sides? So you need a right angle box here, 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 here. And to bisect the sides, if this side right here is cut into 2 equal pieces, I should go boom, boom. Got a question on this guy right here. Let me use a different color. Is that red one and the orange one the same length? So since this went single, single, shouldn't this also go single, single? Are you cool with that? Like if that red one is 10, this is 5 and 5. Doesn't this orange one have to be 10? And that's 5 and 5. And then doesn't this have to go double, 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 double? Check your markings on 14 and 15 and see if you want to keep them or change them. On your isosceles trapezoid, it says there's 1 symmetry line, the perpendicular bisector of the bases. So need a 90, need a 90. Question, is Mr. Orange guy the same length as Mr. Blue guy in an isosceles trapezoid? Are they the same length? No. So that's cut into 2 equal pieces. And then what should this one get? Single tick marks or double tick marks? Doubles. And then how about all of this? 90s all over the place. You got perpendicular bisectors of the sides. All of those got to be doubles. Because doesn't a square have 4 equal sides? So if this whole side was 10, then 5 and 5, that's 10, 5 and 5, that's 10, 5 and 5, that's 10, 5 and 5. It's like double tick marks all over the place, man. One word, meow. What a lesson right there, guys. Thanks for watching this video. I hope you have a great day. Meow at your neighbor. It'd be pretty cool. If they don't have a cat, meow at them twice.